Good morning to one and all. This is a revision class for the DMM2. In DMM2 we have the 5 units. The first one is sliding contact bearing. The second unit is nothing but rolling contact bearing. The third one is internal combustion engines. The fourth one is power transmission systems. And fifth one is nothing but the gear design. Today class we have to go for unit 1, that is sliding contact bearing. First of all you have to know what is a bearing, right? Bearing is a machine element which will support the rotating element. There is nothing but rotating element means the shafts of your machines. The shafts in your machines in rotary condition. If you are using a machine element to support that one, that is called bearing. Simply, a bearing is a machine element which will support the moving element in your machines, right? And the bearings can be classified as three types. The first one is a load based on a contact, based on a lubrication system, right? Based on a load, based on a contact, based on a lubrication system. You can see based on a load, radial load contact bearing, thrust contact bearing. Here you can see if this is the bearing, the hatchet one is the bearing, this is the rotating machine shaft. This machine shaft is called general. If the load is acting along the parallel to the shaft axis, then it is called radial bearings. If the load is acting perpendicular to the shaft axis, this is called thrust load bearings. And based on a contact, full general bearing, partial general bearing, fitted general bearing. You can see the internal circle is called machine element, that is shaft is called. The shaft is called general. If the general is fully covered by the bearing, then it is called full general bearing. If the general is partially covered with the bearing as shown in the here the angle is 120 degrees, that is called partial fitted general bearing. Clear to all? Here it is called fitted general bearing. The diagram should be appear as same as it is, but what is the difference between these two means here the angle of contact is 120 degrees, partial contact, the bearing is placed at a 120 degrees angle only in a contact with the general, but here the general diameter is less compared to the diameter of a bearing. In fitted general bearing, the contact is 120 degrees only, but the general diameter, that is nothing but machine shaft diameter, is larger compared to the diameter of a bearing. This is the difference between full, partial, fitted general bearings. Next, based on a lubrication, what is the necessity of finding the here the lubrication means when the bearing is most of the cases manufactured with the materials, that is the cast iron, babbitt material, whatever it is manufactured with the metals. When the bearing is rotating, the metal to metal contact is there, then there should be heat will be produced due to the frictional force. If you are not using any lubricant, what will be happens means the bearing may be fracture due to these temperature effect, right? Wear and tear will becomes, the bearing may be having the expansion in manner that may causes for the defects in assembly. Then we can go for the lubrication. Then based on a lubrication we have the 5 types of bearings are there: zero film lubrication system, thin film, thick film, hydrostatic and hydrodynamic. Here you can see zero film lubrication system. When there is no lubricant at all, you can see I am explaining by taking this one. This is the machine shaft rotating inside. This is the machine shaft, the red color one is rotating inside of a bearing. This is the bearing casing. If suppose there is no lubricant between these two, the metal to metal contact is there, then those type of bearings are called zero film lubricant bearings. Thin film, if you applied a thin film between these two contacting surfaces, then it is called thin film lubrication system. Thick film, if this general and bearing fully separated by the lubricant between them, then it is called thick film lubricant system. And what is hydrostatic and hydrodynamic? Where the hydrostatic, see here, the oil will be occupies the space between the general and casing always, whether it is rotary motion or not. It is if the oil is placed between, a thick film of oil is placed between the general and casing without contact both components, even though it is in a stationary condition, then it is called hydrostatic bearing. Always the oil will takes a place between the general and casing. If suppose there is no oil at all at initial stage like this, when the general is rotating in clockwise or anti-clockwise, the slowly oil will comes inside, right? And with respect to a speed of a general, the oil will comes inside, and these two surfaces are separated by the oil at high speed condition. If it is rotating with high speed, the machine shaft is rotating with high speed, the metal to metal contact should be avoided by incoming of oil. By the inlet of the oil corresponding to the speed of the journal, the metal to metal contact should be avoided. Then those type of bearings are called hydrodynamic bearing, where the hydrodynamic means liquid dynamic analysis. That is nothing but the fluid, the lubricant can be pumping inside and outside from the bearing with corresponding to the speed of a journal. Clear to all? But based on a motion, we have the two types of bearings. That is nothing but sliding contact bearing. The second one is rolling contact bearing. Here our first unit belongs to sliding contact bearings. When the motion of a journal and bearing is in the form of sliding, that's the mean sliding motion is there at a contacting surfaces, then it is called the sliding contact bearing. The total first unit is depend upon a sliding contact bearings only. In that, the journal bearings, these are also called journal bearings, Journal, journal bearings. Clear to all? Journal means the rotating element, machine element is called the journal, and it is covered by the casing. This casing is called the bearing here. What is the design procedure of this one? Right? And the first step, we have to find out the pressure. By using the design data book, we have to select the pressure first of all. If it is given in a problem, most of the cases the problem will be given like that: a generator, or else a turbine, a impeller, a pump, like this type of words will be given to you. By using that word, you have to select the pressure of that bearing. If it is generator bearing, the pressure may be 700 megapascals. So like that, by using the purpose of a bearing, you have to select the pressure from the design data book. This is the known value, and the W will be given in a problem. Then LD ratios, we have to find out the L value, D value, length of a bearing and diameter of a bearing. Next, after finding that one, you have to check L by D ratio. After finding the length value, diameter value of your bearing, you have to find out the length to diameter ratio, and it should be compared with the design data book. That is nothing but checking. The L by D ratio also there. Wherever you have selected the pressure, there you have to compare with the L by D ratio, whatever the L by D ratio you obtained. If it is within the less than L by D ratio, if you got the less than L by D ratio compared to the design data book at the pressure condition, then these selected dimensions, the L, D and pressure value are suitable. Next step, you have to find out the Zn by P. From this Zn by P, where N means the rotation of your speed of your bearing, Z means bearing modulus, P means Z means viscosity of your lubricant, Z means viscosity of your lubricant, P means pressure on your bearing. By using this Zn by P, this is called bearing characteristic number. By using this one, we have to find out the Z value, and you have to select which lubricant is suitable for that one. Next, we can go for the heat generation. Total problem of a sliding contact bearings or general bearings related to these two formulas only. First of all, that is heat generation and heat dissipation. But to find out the heat generation, we require, these are all the mu, W, V values, and for finding the mu value, we require Zn by P value. That's what we are doing. These are all the steps, right? And we have to find out the heat generation. That means when the bearing is rotating in condition, the heat will be generated. How much heat is generating, that is also called power loss in a bearing. You can see mu WV. This is the formula to find out the Hg. Heat generation is equal to mu WV, where the mu is friction coefficient value, W load on a bearing, V is velocity of a bearing, pi d n by 60, where the d is diameter of a bearing. You have to consider in meters, where n means speed of a bearing. Clear to all? By using V is equal to pi d n by 60, you can get the meter per second, velocity in meter per second. After that, mu you can find out 33.25 10 power 8 Zn by P d by C plus K, where C is clearance ratio, D means diameter of a bearing. Clear? And Zn by P value already we found out previous, and K means bearing modulus number. Clear? Where K means bearing modulus number, that is 0.004, always 0. Less than 0.0025. Clear to all? These are all the formulas are there in design data book. Once you find out the mu, W, V values, W value will be given in a problem. Once you find out the mu value, find out the heat generation in watts. The units are in watts. Later on, you can go for the heat dissipation. That means how much heat is dissipating from the bearing, right? It will defines how quickly the bearing will be cools without lubricant, right? Then HD is equal to Ca into Ta minus Tb, where Ta, Tb are the temperatures at ambient temperature of a bearing. Whatever the values are given, temperatures values will be given in a problem. Those temperature values we have to use here, but you have to divide it by with 2 to get the actual values. And C is the constant value, that is a condition of a bearing. We have to select from the design data book. L, where area means length into diameter, where L means length of a bearing, D means diameter of a bearing. But small consideration you have to consider here, where L and D values must and should in meters, then only you can get the HD value in watts. Here LD values, here the L and D values in millimeters, there is no problem at all. But here the L and D value should be in meters, then only you can get the value of HD in watts. After finding the heat generation and heat dissipation, you have to find out what is the difference between them. If suppose heat generation is more compared to heat dissipation, the bearing get affected by the temperature produced by the frictional force. Hence you have to produce artificial cooling, right? If heat generation is more, you have to provide artificial cooling. If the heat dissipation is more, there is no problem at all. You have to write like that, there is no artificial cooling is required. Clear to all? This is the revision class. I am going for very quick, like why? Because I have to complete the total syllabus. That's what I am going very quick. You to read and follow the previous notes, and once again recall these are all things. Tomorrow we can go for the different types of model problems belongs to first unit, and different types of terms also there. Due to length of video time, I am not substituting right now. Tomorrow class, remaining parameters which are belongs to first unit I will explain, and day after tomorrow class I will go for the revision of problems belongs to first unit. Thank you.